So, welcome to our Python class, second lecture. This is going to be the first lecture where I actually do things, that are kind of interesting other than hello world. This lecture is going to go over basically the capabilities of using Python like a really advanced calculator. When we're done, hopefully by the end of this lecture, if you're taking physics or something like that, you might actually be able to use some of this to do some of your homework. That'd be nice. So, and by this I mean end of this lecture, not end of this class, because that's a long time to be waiting to get knowledge out of stuff. So, what I'm going to do is that I'm going to, so this corresponds with chapter 2. I may sequence break a bit next week with some stuff out of chapter 11, but if so, but regardless, I'll be giving you the readings later today for all this stuff. Okay, so I'll assign this stuff on the textbook. Your readings, to find out what your readings are, you go over here, click on assignments, and it will tell you, hey, this is what you need to read in the textbook, and this is what you need to run in the textbook. It will have like the textbook exercises, and most of the time, I'm just checking to see if you hit the button that said run. Not really too much, but I mean, it's meant to be an easy self-check. At the end of the semester, I basically check, were you doing this? If so, did you do your stuff? So did you go through and read the pages that you were supposed to and run the exercises? If so, great, 5 out of 5 points. I'm not really going to care about your overall score, so to speak, on that, and the percent right and wrong, although I think you should have as many tries as you need, so it doesn't really, you have as many tries as you need, because I will always go for the best answer rather than your first answer. So, yes. So I've still got to do that. I still got to discuss it with the TAs. The earliest will be week 4. The latest the first exam will be week 6, and that really depends on how many exams I think we need. If I decide to go for the more accelerated schedule, it will probably be something like more 4, 8, and 12, just so that we can get more exams in. And general, and since I'm going slower, it requires me to rewrite my exams to accommodate for that. So, so a lot of this is kind of actually going to. Did I answer your question sufficiently? So a lot today is actually going to kind of be review of some basic algebra stuff that you already have mastered, just simply presented in a different context. For instance, operators and operands, at some point you learned those words, even if it takes you a second to remember what the heck an operand is. It's the thing you operate on. And operand is, plus sign or something else like that. In Python, basically things are formatted in terms of statements and expressions. So basically, we write a statement. If it contains an expression, it gets evaluated. So let's go ahead and go and write some expressions over here just on the shell, just so that we can simply see them be evaluated. And then I'll go in detail as to what kind of things or data types we can run operations on. So for instance, you can do stuff like 2 plus 2. And that gives you 4. So we can do operations on numbers. And Python, unlike other programming languages, works more intuitively with some operators. For instance, 5 divided by 2 gives us 2.5. If you're coming from a different programming language, you might have expected 2. More on that later. But it operates the way you would intuitively believe things should work. Also note that because this is being done in a REPL, it reads the expression, evaluates it, prints it out, and then loops through it again. If I were to do this over here, and I'll just create a new file, classroom, okay, and I'll just have to reorganize tonight, which is, and let's call this intro, create a new intro. Can't. So I'll just have to wait until I reorganize this. So data types.py. Okay, so if I just type 2 plus 2 over here and run the program, it will compile, but it won't do anything because I told it to add 2 plus 2, and then I didn't tell it to do anything with it. So remember, your computer is an evil genie. It will do whatever you wish, exactly what you wish, right? You know, so remember, it's those old jokes about like, okay, I wish to be immortal, and then the genie's like, okay, and then doesn't let you stop from aging, and that really stinks because you're like 200 and you have mega arthritis now. So, so on the other hand, when I'm in the REPL, it does print out what I'm doing, and you can see that in blue. If I were to print it out in here and run it, so the advantage of doing it in here is that I don't have to type print every single line. That's what the advantage is. The disadvantage is that really you don't really write full programs. You just do you can do some like one-line operations. Now the better you get, the more advanced those operations can be. They can be really advanced to the point of like you can open up an entire file, add all the numbers in it, kind of advanced in a single line. But for right now, it's fairly straightforward to just demo things to you. Okay, so we can add numbers together. Numbers as we'll discuss in a bit, numbers come in 2 varieties. They come in the integer variety and the floating point variety. In other words, whether or not they come with a decimal point. And Python does care, right? 2 plus 2 gives you 4, whereas 2 plus 2.0 gives you 4.0. Python cares. So you've got your numbers you can add. You can subtract, obviously. You can do interesting, but if you try to do something like adding the string A to 2, it will tell you, hey, you can't, it gives you an error. Now, errors aren't always bad. They tell you what's going wrong, and so so don't just simply let your eyes glaze over it. Try to read the error. Type error. You can only concatenate string to string, not int. So apparently the plus operation is a bit different if we're working with strings. Now remember, strings are what we call text. So we can't add numbers to letters, but apparently, or to text, but apparently I can do something like this. A plus B will glue it together. So you can glue text together with the add operation. That's actually way more useful than it sounds. Which leads to one of those classic questions which I ask on the first exam, which is 3 plus 4 is obviously 7. Obviously, not a trick question. But the text 3 and the text 4 gives you 34, right? Because they're text, right? Notice that this is numbers and this is text, right? So we've got these various operations we can do. We've got these various types. So let me list out what kind of types we have. Okay? So just so we can have a nice list for all our notes. So our first type, which I'll go over first, is called integers. Which are whole numbers without your decimal point. And notice that the text is coming up red. This is something special called a comment, where I have the pound symbol or the hash symbol or the crunch symbol, depending on how old you are. And what this is that basically this is a comment. It says this is for humans only. Please, Skynet, don't read this text, right? This is just for basically if you're in Python, if it sees the hash, it ignores everything after the hash. It says, that's something I can ignore, right? Watch this. 3 plus 4, and then # plus 5. It's just going to ignore that plus 5 because it's after that hash, right? It's commented out, as we like. So comments are used for 2 very important things. The first is what is the most important, which is documentation. You can and this is super important. If you want to know what your code is doing, or you want to explain it to yourself later, commenting. Or if you want to make sure it's documented for other people to read, comments really help. Because I guarantee you, you're going to write something clever. You're going to look back to it a week later and going, what was this mad person thinking? I don't understand this. What kind of insane fugue genius state was I in? So comments will help avoid that, because you'll be able to say, oh, so this is a function that reverses stuff, and that's why I did that. So comments are used for that. The other thing is that you can comment out lines of code. In other words, you can take some code you want, like say you're printing out something, say you're printing out a number. I'll just simply say printing out, or actually I'll just go print hello, like that. And then I'll say print world. If I'm testing it and I don't want the second line to run, I can just simply put a comment in front of it, and boom, no worries. It's also useful for taking notes, right? See, notice that hello ran, but world didn't. And again, your IDE of choice, which will probably be idle, it goes ahead and just simply puts comments in red. So back to your types. Integers, which are your whole numbers without your decimal points. They can be positive, they can be negative, just like they can in mathematics. Now in other programming languages, right? And I'll be saying this again because some of you may have prior programming experience in non-Python. In other programming languages, there's a limit to the range of integers, and integers themselves have multiple types. You have your ints, your longs, your shorts, your long longs, your bytes, all different size of integers depending on the amount of space you need. Python likes to work on a layer of abstraction above all that, above basically the hardware and memory concerns that you might have to think about. So it doesn't care how big or how small your numbers are. Python is super cool with you just simply banging on your keyboard, creating a really big number, and adding it to another really big number, and multiplying that by a really, really, really big number, and churning out the answer for you. Other languages, it will do something weird like return a negative value because of an issue we call overflow. Python doesn't suffer from that because it just simply says, oh, you need a bigger integer? I'll make you a bigger integer. No problem. And again, like I was saying, Python doesn't care about negatives or positives. It will do that just fine. Okay? I can talk about integer overflow some other time, but I don't want to overwhelm you with irrelevant information. The second type of number is floating point numbers, which we simply call float because floating point number is a mouthful. Okay? Also, we often call integers just simply ints because one of the persistent themes about programming is that programmers are very lazy where it's important to be. So less syllables, the better. Ints and floats. Floats for floating point numbers, or numbers with decimal places. Now there are limits to this. And I don't necessarily go over them, but all programming languages do floating points as double precision floating points as according to the double standard. See IEEE double precision, which is IEEE 754. Now what this means is, now this gets into hardware stuff and about bits, and I haven't told you about what a bit is. It's a binary integer. There you go, right? But no, I haven't really explained it or binary systems yet. But suffice to say that there's 74 bits, and integers take up however many bits in your computer that they need. Floating points are limited to 64, but it's a special notation where it's got a sign, an exponent, a fraction, and it uses this fancy-dancy equation to figure out how big it is, or to translate it. But here's the important thing. It does have a range. But that range, that limited range, is freaking monstrous. So it can, so I think the biggest exponent is 2 to the 10 1023rd power. And it can get really, really small. Let's see. So what is the range of this? So, but it will give you, but it will have a number of, how many, let's see. The total precision is 53 bits or approximately 16 digits of precision, which is generally close enough. So this is all a bunch of examples on Wikipedia. But the point being is that doubles have this interesting, is basically they have a range. Don't need to memorize what it is, not even going to bother going into it what it is, because for the most part it is irrelevant, right? So here here like 2.0 plus 4, that gives us 6.0. The big rule to remember is when you mix a float and an integer, the integer gets turned into a float. That's the big rule to remember. Because floating points are more precise. 2.5 plus 4, right? There's no way to add this without converting this 4 to a 4.0, right? Because otherwise we can't accommodate for the half. That becomes 6.5. Okay. Now, what about really, really big numbers? Let's say 100 times 5.5. It will display it in scientific notation for you. It has no problems with that. 5.5 times 10 to the, you've probably seen this on a calculator at some point. You don't really have to worry about numbers this big that much. Any hard math questions I ask you are trick questions. For instance, one of the kind of questions I love to ask are like any big number multiplied by 0 becomes 0, so you don't actually have to worry about the math. So now there's also something else that I need to just demonstrate with floating point numbers, which is what you see with your calculators over here. So I'm going to use a standard calculator. And you've probably seen this. 2 divided by 3 gives me 0.6666667, right? And this is because what? It's an infinite number of sixes, right? Right? What it is actually that like the base 10 number system we have doesn't have a way of accurately representing the fraction 2/3. Similarly, all the math your computer does is in binary, and there's just some fractions that you'll get that lead to weird results. Like, for instance, 1.0 and 2.0, perfectly fine. But on the other hand, 0.1 plus 0.2 gives you 0.3 and a bunch of zeros and a 4. And that's because it's trying to take this 0.1 plus 0.2 and turn it into 0.3, which it cannot accurately encode in binary without some amount of error. In the same way, so if you ever see something like this, and it is super rare, I'm just telling you what it is. If you ever see something like this with floating points, it is just simply the binary, the base 2 version of dividing 2 by 3 in a calculator. Right? This is just simply that. This is just the number encoding. The system we're using is not necessarily equipped to handle fractions. And I know it's like, but there isn't a fraction there. And I'm like trying to say, don't worry about it too much. I'm just saying, if you get this, it's because it's a weird issue with the system, with the way we encode things. Let's see. What other types do we have? We have strings. So all strings are encoded in what we call Unicode, which is basically a giant table of characters. There's some pattern for every single letter has a different pattern of zeros and ones that get encoded, right? Each letter has its own unique sequence, and a letter here is abstract, shall we say. So for instance, you've got letter, so like, you know, a, the letter, lowercase a is a letter, but so is uppercase a, and so is a with a bar on top of it, and so is the number 1. There's a bunch of different types of letters. Anything that is text is a string. It can be as long as we want or as short as we want. Things we'll be getting into later but exist just simply for completeness' sake. Boolean, which is 2 values, either true or false, which is which is very useful. This is for what we'll call Boolean expressions. Lists, which are exactly what they sound like. It's it's an ordered collection of stuff. That is the way I would express it. That is not a very formal definition, but it is an ordered collection of stuff. You know what a list is. Or rather, you intuit what a list is. There's other different types of stuff, but those are the basics that will go on. For instance, there's dictionaries. And finally, the last one I want to talk about or mention is functions, because we'll be writing some of them. Functions, which are special I can't spell apparently. Special operations that either come with Python or we write. So these are the basic data types. The three stuff that will, in the beginning of the semester, really all we work with are floats and integers, which pretty much operate the exact same way. Just one has a decimal point and one doesn't. And strings, which is text, and you'd expect text to work a bit differently. So let's go ahead and see what operations we have. So I'm just going to start off with integers, okay? So we have your basic classical operations that you'd expect to find on a keyboard, which is 2 plus 2, right? We have the addition operation, right? With the addition operator. We have, and it works and here's the fun thing. Order of operations works exactly as it's been defined in all of your math classes. So, right? So, for instance, 3 plus 1 times 15 gives us 18 and not 4 times 15, right? Multiplication and division goes first, left to right, and before addition and subtraction. Parentheses, of course, always go first, right? It works exactly the same way. So we can see that we can do the multiplication operator with the star over here. We can also do subtraction, right? Negative numbers are perfectly fine. Negative 4 minus negative 5. We can even remove the spaces, I think, which looks terrible, by the way. Right? Minus 4 minus minus 5? No, that's negative 4 minus negative 5. 4 minus negative 5. And if you really want to, you can put it in parentheses just to make sure it's explicitly clear. So here the negative operator does double duty as both a binary operator, binary in the sense that you're working on 2 different numbers, and a unary operator. In other words, it's something you do to one thing. In other words, you're turning 4 negative. So here, negative 4 minus negative 5 becomes plus 5. So negative 4 plus 5 is 1. Okay. Now division is the interesting one, because we actually have not one, but 2 division operators. This is a change from all the other programming languages, because the intuitive thing you want to do is say, hey, if 6 is divided by 5, that's not a full fraction, that's 1.2. Other programming languages, they just simply do integer division, which means that they throw out all the floating points, like you would in 4th grade. In 4th grade, when you were doing long division on the board or on a paper, you wouldn't do the decimal points. Instead, what you did was this would be this would be quotient 1 and the remainder would be 1, right? So it would just simply give you the quotient, and again here the quotient would be 1 as well, but the remainder in this case would be 2, right? We'd have divided 5 once and have 2 left over from this. Now, the quotient and remainder come up because we do have an operation to get the remainder. I will get into that. To do integer division and behave like other programming languages, we use the divide operator. So 2 divides gives us integer division. And notice it just gives us 1. And the reason for this is that you might want to keep your numbers as integers, right? 6 divided by 3 doesn't give you 2. It gives you 2.0, right? Anytime you do regular division, you end up between integers. You end up with a floating point number. It's the only operation that's going to happen with, where you use 2 of the same thing, but it gives you something completely different, right? 6 divide 3 gives us 2. Weird, I know, but it's okay. Now you might be wondering, what's the use? Why would we want to have an integer division and a different division? Why do we care about keeping stuff as integers? It's because you can do some neat tricks with integers. The most common thing that we can do is that we can throw out the last digit by integer dividing by 10. For instance, if you integer division by 10, you can throw out the last digits. Or if I say if I've got this number, this 4-digit number, and I want to get the digit in the thousands place, I can just divide by 1,000, and it will just give me the digit in the thousands place. This will come in useful for homework in a couple weeks, where basically we'll use, I'll go ahead and say this, because the students last semester didn't get the message, so maybe if I say it early in advance, you'll get it. This isn't the exact question I give on the exam, but something I often give on the exams is along the lines of, given a number, give me the product of the digits, or give me the sum of the digits, or give me the sum of the even digits, or tell me if the number is divisible by 3 by using one of the tricks that we have, that we can divide. One of the tricks to tell if a number is divisible by 3 is you can add up all the digits in the number and see, and if that is divisible by 3, then the number is divisible by 3, and you can recursively do that. So, for instance, 963 is divisible by 3 because you can add up all these numbers. 9 plus 9, that's 18. 18 is divisible by 3, and we know that 18 is divisible by 3 because 1 plus 8 is 9, which is divisible by 3. Yes?
So will you want us to put the answer in with a decimal point or without that?
I mean, without the decimal point for telling me the sum of the digits. But I mean, it doesn't really matter too much for that. What matters is using this operation, where you'll learn how to do that. All right. Now let's see. So now we've went over 5 operators so far. Plus, minus, times, divide, which are the ones you expect. Then there's integer division, which gives you an integer, right? Think of it as throwing out the decimal points. Okay? There's 2 more, which is times and modulo. These are not nearly as scary as they seem. The reason for times time is actually the exponentiation operator. A lot of times you'll see the exponentiation operator like this, but notice that does not give you at all what you would expect. That's because this is reserved for a binary operation, like literally something you do with binary operations. Like, for instance, that's a binary operation. We'll get into that when we talk about binary systems. You don't have to worry about that, or the binary number system. You don't have to worry about that right now. But notice that we use this, and this is not exponentiation. In no programming languages, I think this is exponentiation. Python had the clever idea, well, since, exponentiation is just a shortcut for multiplication, and we already do divide, we can do times to do exponentiation. So this is 2 to the 8th. And this gives us 256. Okay, and it does follow the rules, by the way. 2 to the 8th plus 2 turns into 258. Or 2, let's go ahead and try 2 plus 2 to the 8th. That also gives me 258. It does the exponentiation before it will do multiplication as well. I'm just trying to show you this works exactly the way it would if you wrote it on paper. Although the paper doesn't necessarily, sum itself for you. So that would be nice. So this should give me 512, right? As well as this should give me 512, I believe. Okay. It's not 2 to the 16th. It would only be 2 to the 16th if I put it in parentheses. Okay? So exponentiation, that's cool. It's just everybody knows what exponents are. The worst if I ask you to evaluate, the worst I'll ever get. So here's things I would ask you to evaluate on an exam. Right? Easy math is the point. Or stuff that looks complicated, but it's not, right? 5 to the 1th power. Or if I'm feeling really vindictive, I might do this. I might do something like this. Anybody want to tell me what that is? Yes? It's 1, right? So it's 5 to the 0th power, right? So here, remember, you've got integer division. This is going to be some small number divided by some really big number, but we're doing integer division. Now, if we had one division sign, this would be 0 point something small, right? Be some small number less than 1. Well, integer division, remember, you just throw it out. So it would be 0 point up. Don't care about the point, so it'd be 5 to the 0th power. Like I said, this is the example of a kind of what you would see on an exam, and again, you do get a practice exam. So so if the math looks hard, it's probably a 0 or a 1. So now let's go over the last and possibly the most important operator, which is the modulo operator. The modulo operator gets into all this funky advanced mathematics about modular spaces, and you can do really funky stuff with it. But for us, we're going to go with a very mundane use for it, which is you can think of it as the remainder operator. It is the remainder you get of a number after you divide something. So for instance, 100 after being divided by, 30. What is the remainder after 100's been divided by 30? Right? 30 goes in there 3 times, which means we take out 90 of it. And so we'd be left with the remainder of 10. Right? Remember how or an easier example with less big numbers. 7 mod 3. Right? Which gives us 1. Because 7 divided by 3 gives us 2. We can go into there 2 times. If we go into there 2 times, that means we subtracted 3 times 2 out of it, which is 6. And that gives us a remainder 1. Right? You can think of divide as giving you the quotient and modulo as giving you the remainder. Now you might be thinking, why in the world is this useful? Why are you teaching this to me? This isn't a math class. I didn't sign up for this, even though I totally registered for this class. But I mean, I didn't sign up for this experience. So So why am I telling you this? Because one of the because we use two common tricks with the modulo operation. The first is to check if numbers are even or odd, because and a common thing we like to do in with loops is do one thing on to repeat doing one thing, then doing a different thing. So like go left this time, go right the next time, then go left, then go right, then go left, then go right, or something like that. Basically, fluctuate between doing one thing and doing another thing. And using a counter and then checking if that number is even or odd is pretty useful for that. So one thing we can do is basically, as you'll see later, is that we can check, okay, hey, if the remainder after we divide by 2 is 0, then it's an even number. And if the remainder of this and this big number, it's odd because the remainder after we divide by 2 is 1, right? The only remainders possible are 0 and 1. So that's one trick, modding by 2. The other common thing we mod by is 10. Remember how I said the way you can get the last digit of a number is by dividing by 10. Throw out the last digit of a number is divide by 10. Well, if you mod by 10 instead, you throw out everything else instead. So for instance, 124 0174 mod 10, that gives us the last digit. It throws out everything but the last digit, which is pretty useful if you want to go through it once at a time. You can sequentially go through and divide things by 10 and mod things by 10. We're not going to use these things. Now, if you're worried about this and all this flow of information right now, don't panic. I know it's a lot, but the reason I'm presenting it is just simply for the sake of completeness. There will be individual exercises we will have that go over these particular operations in their own space, right? You don't have to memorize it or anything now. And again, I just told you, the modulo operation seems scary, but there's really two cases we use it for. Checking if numbers are even or getting the last digit. So, what about floating points? Do we have extra scary sauce there? Well, with floating point numbers, they work exactly the way you would expect, right? Which is, you can add numbers together, you can subtract them, you can multiply them together just like regular numbers. You can divide them. 4.3 divided by 2.4 gives me some awful abomination of a number. Okay, what about divide? Can I divide two floats? It does something weird. Wow. It just throws out all the stuff after the... What does it do? Gave me a decimal, but threw out all the stuff after the decimal point. It's weird. I've never done that actually before. I was just curious what would happen. I've never, ever seen somebody need to divide two floating points, so I'd ignore it. Same with modulo operations. You can totally mod things, mod decimals, but I've never seen somebody do it. Oh, syntax error, unexpected indent. I'll get into indentation later, but I didn't like the fact that I had a space in front. So I've never seen somebody do a modulo operation, even though I know you can between two floats, because it gives you some weird numbers. So don't worry about doing modulo operations or integer division with floating point numbers. There's really not a use case for those from where you're sitting. I've never done it, and I've been doing this for a while. Okay? So let's go ahead and list down. I'm going to go and list all the operators for this that we care about. Plus, minus, times, divide, and mod. And then for floats, we just care about plus, minus, times, exponentiation we do care about. Let's go ahead and do 2 plus. So for instance, 2.0. So for instance, 2.5 squared, right? That's 2.5 multiplied by 2.5. That works exactly like we'd expect. If you want a cheap way to get the square root of something, right, you can multiply it by you can give it the 1 over 2 exponent. So, and divide. That's really all we care about. Now, what about strings? Well, strings, the addition operation is something we call concatenation because it makes us sound really smart. But basically, anytime we want to basically glue some strings together, we can use a plus sign. So here, hello and world. Actually, first let me leave out the spaces over here because I need to remind you that the computer is an evil genie, so it will print out hello world, all one word. It glues your text together exactly as you want it to be glued together. If you want a space in there, you better put that space in yourself. Right? That's a common mistake. I'm probably never gonna count offer it on an exam because it's silly, and as soon as you make it in a program, you immediately understand what you need to do to correct it. If this happens, do not feel stupid. I make this mistake all the time. In fact, I've made it thousands of times, and I've seen thousands of students make it. Still make it. Don't worry about it. And this is actually a brief aside I must go into here. There are a lot of people in this classroom who do have some amount of prior programming experience. For those of you who do not, this can be very disheartening, where you see basically people just kind of blaze ahead and you're stuck here on this stupid error, and then you ask your TA or me for help, and I fix it in 5 seconds. And that can be really disheartening and make you feel really dumb. You are not dumb. The reason I can fix that in 5 seconds is because I failed a heck of a lot more than you. I have failed more times than you have. I am failure incarnate. I am so good at failure that I can recognize other people's failure really quickly. Okay? But really, I say it in jest, but really, the difference is, with experience, is that I have made the mistake a whole lot. Once you make a mistake, you know how to fix it. Or at least, if you make it again 10 weeks later, it takes less time for you to fix it again. Now scale that up to the fact that I've seen students make mistakes all the time, and students tend to make very similar mistakes. So I immediately kind of know where to look in your homework for that particular mistake that's giving you a bug, so I can fix it very quickly because, not only have I made a similar mistake, but 20 of your classmates have made the exact mistake, So do not get disheartened if you see basically me just work on what seems to be another level. That other level is lots of failure. So don't be disheartened. There's a lot of parallels between music and computer science in the terms of discipline that it requires. In the sense that musicians require a lot of practice to become really, 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 really good. I know because I minored in music, and I was terrible because I didn't practice. On the other hand, similarly, like music, we demand basically perfection out of your code. We demand that it runs, that it does not have a single syntactical mistake or something like that. In music, we demand that you definitely don't play when everybody else is not playing. So, so there's a lot of parallels like that, but the way you get good is you practice. That's why I will give you homework essentially every week. It's so that I can encourage you to practice, okay? So I will make mistakes. Sometimes they will be completely intentional. Sometimes they will be completely unintentional. And sometimes I'll go, aha, I was just testing you, and that was probably unintentional, but was it really? So, all right, so we did addition operation with strings, and that just glues stuff together. You get into this kind of issue where you might want to, and you can do this in other programming languages, and this is one of the nuisances in Python, that if you're coming from another programming language, you might expect this to print out the string hello and 5, but it says you can't combine strings and integers. You can only combine strings and strings. So if you want to do something like this, what you have to do is use a special function, a special command that's built into Python, just like print is built into Python to print stuff out. str, again, programmers being lazy. This is short for string. Anything you throw in between those parentheses over here gets gets stringified, gets turned into a string. Right? Doesn't matter what it is, get turned into a string. Oh, it was already a string? Good for it. Still turning it into a string. Right? Doesn't change anything. But the point being here is that this str converts things into strings. There's a function for each type, str, int, and float, which converts stuff into other things. We'll go into more detail about that. But this is useful for concat. But I figured this is good to bring up for concatenation. Question?
You just put the parentheses around the bottom and do the same thing?
No, because parentheses have a special definition.
I mean, not parentheses, like the exclamation, the quotations.
Oh, yeah, if I put this around it like that, that would totally work.
Oh, cool.
But sometimes we want to work with variables that hold integers, and I haven't gotten into variables yet because I'm still talking about data types. Okay, what else can I do to these things? Hello. So can I do hello minus world? That doesn't really make sense, and unsurprisingly, no. It says that it's an unsupported operand type. Right? That means that the minus operation between string and string doesn't really make sense at all. Unsurprisingly, multiplication does not work, but it says but it gives you a different error here. It says you can't multiply sequences by non-ints of type string. We'll come back to that. Unsurprisingly, you can't divide. Okay, and now we're back to that. So one of the things you can do in Python, which is really cool, is that you can take a string, so HELLO space, and then do multiplication operation, and it does kind of exactly what you'd expect. So multiply by 3, it gives me hello, hello, hello. That makes sense. Python likes to make sense. So if there's an operation available that makes sense, so the two operations that you can do with strings is plus and I'll put this in parentheses, times int. You can times it by a number to basically replicate it. Okay. All right. So any questions on variables so far? On not our variables, our data types so far. Integers, floats, strings. All right. So what I've been playing around with at this point are called literals. It's a stupid name for it, I think. But honestly, you need some name, and I don't think there's any name that's less stupid than literal. So, because it's like, this is literally a 5, this is literally hello, it's literally a value on the screen. Right? Most of the time you don't work with literals, you work with variables. Like, right, most of the time in physics you don't get to work with those numbers, you work with equations, and then you plug in the numbers into the variables. Right? So similarly, they are variables. Unlike physics and mathematics, we actually have the advantage here in that our variables aren't terrible. We have a computer. We can take advantage of the fact that we don't have to name something t, we can name it time as a variable. Right? We can actually spell it out. And in fact, I highly recommend it because it helps you remember what the heck you're doing. So you can store anything you like in a variable using the assignment operator. So for instance, x equals 5, and I just totally said something that's going to confuse the heck out of you in some way, shape, or form if this is your first time, because technically x is not equal to 5. What I did is that, even though I read it that way, what I did with this assignment is I said, I'm going to take what's on the right and store it in the variable on the left. I'm going to take this value and store it in here. I'm going to assign 5 to x. Now, the reason I use the equal sign is because we're lazy, again. And also because we've got some restrictions on our text. For instance, in a lot of like pseudocode, which is code that's just kind of more closer to an algorithm and doesn't run on any particular computer, you'll often see assignments as like an arrow pointing this way, right? Store 5 in x. Right? We're not saying x is equal to 5 because we might change what x is. We can actually change what variables represent. But if you translate this could be read as x is less than -5, which is It's not true right now. And so what if it was a bigger arrow? Now it's just kind of weird, and that took 3 keystrokes. So some languages used to do this, which has been given the antonym, it has been named after this fact as the walrus operator. If you look at it sideways, the walrus operator. And some programming languages like Go still use this for special purposes. Really cool stuff you can do with this. But eventually it's just got shortened to this, which is basically we will. So here, if I were to print x, which I could just simply type x over here to do, it says x is 5. And then I can assign a new value to it, x. Now in other programming languages, so Python is what we call a weakly typed language. Many other languages that you may have learned if you were coming from a previous class. And again, I don't expect you to have any prior programming experience. The reason I keep bringing up if you have prior experience is because I have to cater to both people who do and who do not. So don't feel like you're missing out if you didn't have prior programming experience. But I have to clear up confusion, subtleties between languages. There are languages that are what we call strongly typed, where basically you declare what type of thing X is. Like X can only hold integers, or it can only hold strings, or it can only hold doubles. And the reason you do this is that for compiled languages, this makes it more efficient to compile. And it also prevents you from accidentally changing the type out from under you. Static languages like to be fast, fluid, and agile. And they like you to be able to code fast. So we don't have any time to write any of those, type safe stuff. So this is what we call a weakly typed language, where basically X can be whatever we want. We can change X to a string right now. And it's totally cool with that. Now, believe it or not, this is an expression, right? It's a very simple expression that I just wrote here, right? It got read, it evaluated, it said, and it just basically went into its memory and asked, what is X? Hi, I'm a string. Great. Let's see this work in kind of a more mathematical form. So let's make X 5 again. X squared, right? So you see X squared, the computer sees X squared. So it goes, okay, X is 5, so I'll replace X with 5, and I'm going to evaluate the entire expression now, which is 25. Now, one of the things that Python's nice about is that basically, when you go to a line, those variables won't change mid-line. But you can change okay, now here's so like I can do totally, let's see, I could do X is equal to 5 plus 7, right? This gives me 12. So remember, the thing on the right gets stored in the left. So this is very important. We evaluate the thing on the right, and we store it on the left. So here's the big, kick in the head over here. So X's current value is 12. So X is equal to X plus 1. Now in math, this makes no bloody sense. How can X be equal to itself but bigger, right? That's not what I'm saying over here, right? Even though this is a bit of an advanced example, I want to just say it to make you understand this is not the equal sign, even though I totally say equals, and you will say equals as well. This is the assignment operator. What we do is we evaluate the thing on the right first, and then we store it in the variable on the left. Okay, so let me replace it with something easier to read. Y is equal to X plus 1. Okay, we evaluate it. What does it evaluate to? 13. And so now Y's value is 13. Now, this is kind of important here because this is what works differently than in mathematics, right? If I were then to say X is equal to 5, that will change X's value. It's not going to change Y's value. y is still going to be 13. You might expect it to change to 6, right? If you're thinking about it in terms of mathematics. But remember, that's not the equal sign. This is the assignment operator. It's a subtle difference. We evaluate the expression on the right and store it in the left. Now, you might be going, why is it like this? Because trying to keep track of a million variables in your head and all the relationship is terrible. It's simpler if we just simply lazily evaluate things. Y is equal to x plus 1. 12 plus 1 is equal to 13. Great. Y is now 13. I'm not going to try to store that the y is equal to x plus 1. I'm storing y is 13. Now if I change x to 5, that's not going to change y's value. Everybody understand that? Okay. So similarly, x is equal to x plus 1. What is x right now? X is 5. X is equal to x plus 1. If I were to say y is equal to x plus 1, you would say y is now 6, right? So if I say x is equal to x plus 1, what is x's value now? 6. So what is stored on the right goes into the left. This is one of the more harder things to understand. I'm sorry for hitting you with it so early. But, and here's the but, I don't expect you to master this for a couple weeks. So you've got time. This is one of those subtleties. There's a lot of rules I'm throwing into you all at once. But I want to get them, if there's something to remember out of this lecture, is that this is not equals. This is assignment. The thing on the right gets stored in the left. You evaluate the thing on the right first. That means you figure out what it all sums up to, or divides up to, or multiplies up to, or whatever it is. And then you just take that and throw it in this little variable over here that's got a label. So let's talk about what we can store in variables. We've seen that we can store ints, we can store floats, we can store strings. What else can we store in this? Well, the answer in Python is anything we bloody well want to. Anything that will fit. For instance, remember how I had this, how we had this print function, right? Print. So I'm going to go over here into this. So we have print hello. I run it. Prints out hello. Great. So let's go ahead and just say I'm going to create a variable called f for function, right? Everybody knows f. F is equal to print. Well, I run it. It's going to be legal. Doesn't yell at me. This is new if you're coming from a different language. You're never going to see me. The only time you're going to see this is now and like at the very, very end of the semester. So this is just to get into the head the point that this can store anything. And so I can totally say f hello. And now it will go hello, hello, because f is now just a renaming of print. So I can totally store a function in a variable. End result, you can't do that in a lot of other languages. But in Python, you can store anything in a variable. Now, functions, you're never going to see me do that again, because that looks terrible, especially if you're just beginning. The point being, doesn't matter what type it is. If it's an integer, float, string, it can be a variable. Okay, are there rules for naming variables? So far, you've just seen me give one-letter names to stuff. And you'll do that a lot. X, Y, Z, A, B, C. And then you're going to be like, what the heck was B? What the heck was A? What am I doing? Why am I here? I don't remember any of this. So you can name, so variables can have long names. So for instance, you could, temperature is equal to, 37. 37 degrees Celsius. Healthy. That's 96. That's 98.6. Interestingly enough, 38 degrees Celsius is a fever that is above 38 degrees Celsius is the temperature in which you should get concerned for an infant under 6 months. Very short range there. So you can name them however. In fact, you can give them multiple words, kind of. So, however, there's a bit of an issue. Largest temp for temperature is equal to 40. Notice it says invalid syntax. Doesn't like the space in there. So there's a trick. If we want to give a variable that has like 2 words part of it, the way we typically do that is you can use underscores to connect things, like that. Or you can use something called camel casing, where you start out with lowercase, and then then any additional stuff is capitalized. Largest temp we saw. It's called camel case because it has a lot of humps in it of capital letters. It's a terrible name, a terrible pun, but whatever. You remember it now. Largest temp we saw. Okay, so either use underscores or camel case. Which one is the correct one to use? Which one you should use? So here's the answer. Python officially likes to use underscores. I will be using camel case because camel case is the way Java has done it, and I did Java long before I did Python, and I'll be darned if I change now. The most important thing is that when you are writing a program, don't mix the two. You do not mix and match. So, for instance, you should not use underscores for one variable and then camel case for another variable because that will get confusing in a heartbeat. Okay. A convention is that if you have a constant, something you don't want to change, we type it in all caps. So, for instance, pi, which we probably don't want to change, is 3.14159, which is enough. Okay, right? So what are what are the rules we can't do with variables? Variables can be pretty much as long as we like, but they have to have only specific characters are allowed. Alphanumeric characters are allowed, as are characters in other languages, because Python decided not to be Anglo-centric for once. So let's say the variable. So let's go with the Japanese hiragana for ko. Ko. Here we go. And then is it control? Super. There we go. Is equal to hello. Okay. Or actually, better yet, let's go ahead and say that is equal to the string ko. And now so notice that it totally accepted that. So if you're coming from a different language and you find it easier to type variables in your own language, feel free to do that. You be you. It totally works, too. The rules are, though, that you cannot start variables with a number. You can't start variables with a number. Okay? You can't have and you can't have punctuation marks in them, pretty much, is the big thing. So anything like an ampersand, a dollar sign. Actually, some languages allow dollar signs. Yep, so no dollar sign for you here. Let's see. However, you can use numbers elsewhere, like this has a num1, or actually another one is x1 is equal to 3, x2 is equal to 2, x2, so say you have like 3 x variables, right? You can name them like that. So you can totally do them like that. So numbers just not allowed at the beginning because that confuses your computer. That's why. So no punctuation, no numbers at the beginning. The only punctuation that's the exception is the underscore, and that can go anywhere, including the beginning, which is typically used for like weird stuff like you want to say this is a private variable that other programs can't see. Right, you can totally, there's some weird things you can do, like with 2 double underscores. I'm not really going to get into that. Dash is not allowed because dash is subtraction, right? So let's just go ahead, and we can see we can move these, we can play with these as many variables as we want. x2 minus x1 minus x2 times x3, and it has no problem manipulating those in any way, shape, or form, right? So you can store them in variables like that. Okay. And that's fairly straightforward. So this is fairly straightforward as what you can do. So those are your data types, and that's what you can do with them. There are some other data types we can do, other things we can do. Let's see. The big thing we can do is like get input. Let's see. So we can say, for instance, print, please enter a number. Okay, and this will ask you to please enter a number. And this is currently the only way we have to talk with the computer. We'll be transitioning away from using input eventually, but in the beginning, when we don't use functions and we don't use parameters, we will use input a lot. So please enter a number. Input says, hey, program, stop here. Wait for the person to input something. Okay, so I'm just going to run this. It's going to say, hello, please enter a number. And then input's on the next line, and then it says, hey, input. Now what does input do? It's notice that it hasn't printed out thanks yet. It's not thanking me for giving it a number because I have to give it a number first, right? Remember, it's all sequential. Print hello, print please enter a number. It's waiting for me to input, and it will wait until one of us is done. And well, it's plugged in, so I'll probably, I'd probably go before it did. So it can probably outwait me. So I'll go ahead and give it a number. It says thanks. Now it's not going to do anything with it because I haven't told it to do anything with it. But what you can do is once you use a function like this, you can store its result in a variable, right? Everything in Python is an expression. Every line is a separate expression. And when we have an expression, we can say, take the value that results on the right and store it in the left. So we'll say that its user input is equal to input. Store input in user input. And then it will take thanks. Please enter a number. 5. Thanks. Now I haven't done anything with it yet, so let's go ahead and say print. You entered colon and then plus user input. Now here's the thing. I told it to enter a number, and I did enter a number. But what I entered was a string, right? Remember, I entered a string. So anytime I'm dealing with text, I'm dealing with strings until otherwise specified. So I'll make it a bit more explicit. Please enter a number. My number is 17. You entered, my number is 17. Also, notice I made that mistake I told you about. Totally didn't put in a space. Ooh, even better example. 4. You entered 4. Okay? Now let's see, now to talk about the whole idea of conversion. So you doubled, and now let's print it out doubled. Okay, let's print it out doubled. Okay, doubled is equal to user input times 2. Now, this is going to run, but this is a bug, right? Because remember, I'm still dealing with text over here. And you can multiply string by an integer. Please enter a number, 4. You entered 4, doubled 4, right? If I were to run this program again and say 14, give me 14. Okay, so if I wanted to deal with integers, well, I used str to convert a number into a string. How could I convert a string into a number? Int, right? It said there's one for each type, so int is the special command that will take something, and if it can, it's going to convert it into an integer. And if it can't, it's going to throw a hissy fit at us, right? So here's a number. Enter a number, 4. Can only concatenate string to string. So I turned it into an, well, that's annoying. So let's go ahead, and for right now, it's saying basically now it's an integer. I don't want to add a string and an integer together. So I'm going to go ahead and first, before I get into fixing that, because I want to present something different, before I go into fixing that, I'm just going to put it in a different line for right now. Then I'll go back and fix it. Print user input times 2. Please enter a number. 4. Doubled 8. Right? So converted it into an integer. Right over here, we converted it into an integer and multiplied it by 2, and then we printed out that result. Now, we wanted to go over here and add it to over here. But this entire thing is an integer, so it needs to be converted back into a string to concatenate it. So you can totally nest your function calls like this. So now this may seem like a hard second lecture. I urge you not to be intimidated, because I am literally just trying to show you like the pitfalls that what are the intellectual pitfalls that you have. And my philosophy is, if I show you these guys, the things that freshmen typically have, and freshmen and entry-level programmers have trouble with, like in the first semester, in the first couple of weeks, if I show you that right at the beginning, you're not going to be surprised by it later. Okay? Please enter a number. 500. You entered 500, and so now parentheses work into out, right? So we take user input, which is 500, turn it into an integer, multiply it by 2, and then turn that result into a string. Typically, we don't need to do that too much. In fact, there's something easier we could do. Create another variable. Right? You entered user input, and so now we'll create a term called doubled, which will have the user input but multiplied by 2, right? And then we can turn that back into a string. Or alternatively, and the reason I'm saying all alternatively, and I'm jumping between alternative and alternative, is because I will get a lot of you saying, well, was it okay if I did it like this, or if I like this? Not this example, but like for homework in the future, you're going to ask me, is it okay if I did like this, this, and this? And the answer is, of bloody course it is, right? Unless it like misses the point of the assignment, it's okay that there's some minor variation. It's not an exact, there's no one exact way to do something. There are ways that are more concise. There might be ways that are easier. But if it works, gosh darn it, it works. So one thing we could do is that we can take our input and immediately turn it into an integer. And then we don't need to do int over here. And we'll just simply say, hey, here's our user input. And now I have to turn both into strings, but now I know everything I have to turn everything into strings. And it's easier for me to remember, maybe. The homework that you will be getting next week is a fairly straightforward one. It will consist of 2 exercises. The first exercise is what I call messy chocolate, which is pretty straightforward. There's this thing we called the BMR, which is slightly related to the BMI because it's health related. BMR is your basal metabolic rate. Your basal metabolic rate is how you digest most of your calories, or how you not digest but use most of your calories. This is the calories you consume to keep your heart beating, your muscles moving, your lungs breathing, and also to digest your food, right? It takes energy to get that energy of the food you eat. Basically, it is the stuff that you consume just by being alive. You would consume it whether whether or not you're laying in bed or not. It's the majority of your calories. What we'll be doing is we're going to be writing a very simple calculator, which is how many chocolate bars do I need to consume in order to meet my basal metabolic rate? And it will probably be like 7 or 8. So, but it's a fairly simple conversion problem. It's a fairly simple equation. And it really shouldn't sound too intimidating for you guys. Even if this was intimidating, and I recognize that this might be intimidating, but I wanted to go through and talk about the variables. Now, I will be assigning work and exercises from the textbook. It has some exercises here right at the back, and I'll assume them, right? And sorry, and I assume you're going to go through them. But look, evaluate the following numerical expressions in your head, then use the active code to check the results, right? Then here's some problems over here. Elsewise, one of my personal favorites, drop the code and arrange it in order. Very useful. A lot of quizzes I will give are simply put the code in the right order. So, all right, but I will assign these textbook exercises. I'll upload this lecture and the previous lecture today, and then that's it. All right, if you have questions, complaints, criticisms, please come and see me.